Hello everyone and welcome back to the channel. So this is going to be our very first episode of the multi-tenant SaaS using Django tenants and React. Just like I promised you in our last video, the very first episode is going to be a system design guide where we'll discuss everything from our system design and architecture from low level to high level system design. So if you're a developer and you're looking forward to build your very first SaaS using Django tenants and React, or you just want to level up your system design, then this video is right for you. So let's get right into it. Okay, now just in case you're joining us here for the first time, this is a loan management SaaS that is called Lendpoint. So we already have a live system that is active. So if you want to go check on it, I'm going to leave a link into the description so that you can go ahead, test it, and also give us feedback. So in this series, we're going to be building this application a step-by-step approach. But if you want a complete and production-ready source code for this application with the documentation, then be sure to check the link in the description with the production-ready and documented source code of the application. Now let's start with the front end. Now for the front end, we are going to use React and Tailwind plus ShadCN for our UI. Then for the backend, definitely we're going to be using Django REST framework for our API, and also Django tenant that is going to be like the engine of this project. And also for the database, you're going to be using Postgres SQL because that is needed for the schema isolation when you're using Django tenants. So, and for the infrastructure, just like I mentioned, we're going to be using Docker, Nginx for handling our static files and also for load balancing. We are going to be using Celery for the background task, as well as Redis as our result backend, and also static file caching. And now before we can even jump straight into the system design, let's talk about some of the strategies that we have when it comes to building a multi-tenant application using Django tenants. We have different approaches to it. Each and every one of them has their own share of advantages and also limitation. So we're going to start with the first approach, and that is the shared schema. So in this approach, the tenants share the same table and they're just being filtered by the ID. Now, while it might be fast, this is not the best approach when it comes to security and also data leakage. So when you filter tenants by ID, there are chances that you might leak the data of one tenant to the other, and that is not something that you want in a financial system like a microfinance SaaS. And the other approach that we have is the schema per tenant, where the database, the Postgres database supports schemas. We do have schemas, and we do have a public schema, and you can also create other schemas. So that is the approach that I recommend for this one, because it's less likely that you're going to leak data. It's best for isolation for tenant A to be able to see the data for tenant B. So that is the approach that I'm going to recommend, and that's what we're going to be using in this project. We are going to be using the per schema approach, where each tenant is going to have their own schema. And then also, if you want to scale, if you want something that is really strong in terms of isolation but expensive, then you need to go for the per, that is the separate database per tenant. So that is an approach that you can scale later. You can start with this one because it's easy, but this one is going to be really hard to provision and to backup. Now, with that said, let's go into our system design diagram and look at some of the services and the infrastructure that we're going to use for the project. Now, this is going to be our system design for our project. I'm going to walk you through everything and also explain why I've gone for each and every service that we have over here. So the first thing that you can see here is that we do have all the services Dockerized, and each and every service is going to serve a specific purpose. The first one is that we do have the first service that is going to be the Nginx service here. Then the second service is going to be the Django core or the application itself. Then we also have the data layer. This is where we have the Redis that is going to act as our result backend, and also RabbitMQ as our message broker. Fourth service is going to be the salary workers and also the salary periodic scheduler, as well as database and the support service that is going to be Cloudinary for our documents. So let's start with the first service over here, that is the Nginx, and they're also going to explain some of the roles that Nginx is going to play here. So from the very start, we have the request coming in from the internet, and for that case, we are using Nginx here as our proxy. So as you can see, the requests are coming here. So instead of the request hitting our application directly, we are going to have Nginx over here as our reverse proxy. So Nginx first received the request. So as you can notice that from the internet, the requests are encrypted. So the first thing that it will do is that it will encrypt or terminate the HTTPS to HTTP, because our application over here do not need the HTTPS, and termination of the HTTPS within our application is really expensive. So that is the first thing that Nginx is going to do, is that it's going to terminate that request, decrypt it, and also send the request to our API that is going to be in HTTP. And then it also acts as a reverse proxy over here. So instead of the request directly hitting our Django application, we are going to forward that request to our Django application. That is if it's a dynamic request. But if it's static file request, let's say for an image or just any other resource, we are just going to cache them here and then send them back to the user. So think of Nginx as the traffic controller here. So apart from just serving as a reverse proxy and also encrypting the request, Nginx is also going to act as a load balancer here. So as you can see over here, we can have multiple servers for our application, and that is called horizontal scaling. So once the request comes over here, the Nginx is going to act as a traffic cop, where the requests are going to be distributed evenly depending on the server. So you can see that we have the server 1. We can also have a different server here that's going to be server 2. So once your application, so that is it for our Nginx. Then once the request leaves the Nginx service, it goes to our Django application. This is going to be the core API for our system. This is what has all the authentication, all the loans, all the payments, all the billing, all the support, all those applications that is going to be on our service too. Think of this as the web service. So the web service now is going to depend on the Postgres database. So that is why we have the fifth service over here. That is going to be our database. And for this case, we're going to be using Postgres database for the system, because Django tenants do require Postgres as a database, because we're going to use a custom backend for it, and it does require Postgres. So that is going to be our database service. We also have a backup for our application. So the database is going to be backed up. There's a service that we're going to add for just periodically backing up the database either in. And now for our Django application to work asynchronously, we are going to be using some background services over here. Redis is going to act as our result backend, while the RabbitMQ is going to be our broker that is going to store the messages, and then the workers are going to pick the messages from the broker, and then they are going to execute them. So that is going to be the flow for our data layer. And then the asynchronous layer over here, that is going to be the salary scheduler, that is going to be scheduling tasks such as the mini statements, and also other expensive tasks that you just want to automate, such as mini statements, dividends for the organization, that is going to be done via the scheduler. Then the workers are what are going to be consuming the task. Once they're done, it's going to return them back to the queue. And then lastly, in our service layer, we are going to be using Cloudinary, that is going to store our static assets such as images and also media files. We're going to be using Brevo for our email service, as well as, so we're going to be using Brevo for the email service as well as SMS services. For the SMS services, we're going to be using the Mobitech API to be able to receive the SMS. Other services that I haven't mentioned here is that we're going to be using Africa Stocking for the USSD API. Remember, this is a multi-channel access where we're going to have the web access for the organization admin. We're also going to have a USSD for the members to be able to query their balances as well as apply for loans via USSD. So that is it for our system design. We have Nginx at the very first that is going to just control everything that comes to our server and also act as a load balancer. Then Django as our API, that is what is going to process the dynamic requests, database for backup, and also the service layer and the asynchronous tasks. Now, once you've looked at the architectural design, now let's go ahead and also looked at some of the application that we're going to have. Now, when it comes to Django tenants, we have two ways of listing our applications. We do have the shared apps list as well as the tenant apps list. Now, for the shared apps list, this is where we have the framework and the core. Now, the framework, this is going to be things such as the content types, the admin, if you're going to be using the Django admin, as well as other third-party packages such as Jasmine, if you want to use a custom admin that is made by the Jasmine package. So that is where you're going to add all those framework and other core application that is going to run your system. And when I mean core application, these are things such as the accounts. We definitely need the accounts both in the tenant as well as the accounts tenants as well as the shared application, because that is what is going to be used for login. And we also have the clients. Clients is going to be where we have a record of our tenants. So instead of calling it tenants, you can just give it any other name like clients for this case. Then for notification, this is also going to be for both the shared as well as the tenants, the subscription, and also the public audit. So these ones are going to be in the public schema for the Postgres. Billing, super admin. This is just going to be for a custom admin specifically made for the admin or the platform user or the platform admin of this application. So that is how I like to structure them. Everything that is business logic, keep them inside the tenant apps. So once we have figured out this, let's go ahead and just see how Django tenants work at its core. What's the logic between Django tenants? How does it work? How does routing occur? So that is what we're going to move to next. So let's look at the life cycle of the multi-tenant request. So in a typical request, you just have your request coming in, you have the middleware, then it will just go directly into the view, because we basically have one database. But with Django tenants or with multi-tenancy, the logic is going to differ just a little bit. So what we have over here is a request coming in. Then the first thing that you're going to have is that you're going to have a middleware just is sitting around just before it hits the database. In a typical Django application without the multi-tenancy, you're just going to have the request hitting the middleware with the security, right? The sessions, the messages, then it comes to your view. But in this one, we do have a middleware here. Then we have the Django tenant middleware or just a custom middleware that you can have. By default, I don't recommend that you just use the default Django tenant middleware. What you want to have is a custom middleware that allows you to extract some data. For example, if you want to extract the subdomain, the IP address for that incoming user, then that is where a custom API for your Django application is going to be important. So in this case, the middleware hits the custom API. That custom API is going to set a search path for Postgres. Then once it has set the search path, it's going to go to the database router. Django tenants has a database browser that is going to route that specific tenant to the right schema. So we have the request coming over here. The middleware will extract the subdomain or the tenant name. Then the database router will now match that tenant name with the right schema. So that is the Postgres router going to route that subdomain to the right schema. So that is really important. This is like the heart of it. The middleware and the database router are really important, because if you get it wrong, it's going to mess you up. And then once we have switched to our router, now the authentication can now happen, because if you have the authentication before the middleware switching, before the database switching, we're going to get all sorts of errors. And now after authentication has happened, we can now gracefully execute the views and our serializers. Now for the database design over here, I did gamble through a few of them before I finally learned the very best way to be able to manage your users, because the documentation doesn't really cover a lot when it comes to authentication and everything. So you really have to dig deep and be able to come up with an approach that works well for you. So after multiple attempts and also just testing out different ways to be able to handle authentication for Django tenants, I did come up with this approach over here, where we do have two separate apps, that is the accounts app and also the tenant account. So the accounts app, it's going to stay in public and it's going to have a model that is called global user. So the global user is going to be for the identity. It's going to have different types of role. For example, we do have the super admin, the platform staff, the business staff, and also the business member. So global user is just for identity. That's why we have very minimal fields over here. For example, the email, the first name, the last name, only the fields that are going to be used for identity. And ideally, you don't even need the first name and the last name, but I just include them for identity, maybe sending some welcoming emails after login. That is why I kept them here. But the global user should be very minimal, only the identity fields such as email and phone number. So that is what we have in the global user. We also have some categories such as super users, platform staff, business staff, and also business member. And then in our tenant application, we are going to have a tenant user application that is going to be linked with a one-to-one relationship with the global user. That is what is going to be linking the global user as well as the tenant user over here. And then we are going to map these roles. Notice how we did have roles at the very top. So we're going to map the roles of this specific user to the roles that we do have in the global user. For instance, we do have this user over here. Let's say we are going to create a user of type of member. So we're going to map that role in the global user as member. So the member is going to be mapped to the tenant user. So the global user is going to be for identity. Then it's going to be mapped to a one-to-one relationship with the tenant user, which is going to map the roles over here with the global user. So inside the tenant user, this is where we can now have the first name, middle name, and last name, as well as the email, as well as allowed apps. So this is now going to be the business logic. This is where we're going to enforce some policies. So once we have the tenant user, we can just go ahead and just extend with many models as we have, because today we might have member, but in the next day we might want to have another model for an auditor. So instead of just jumping everything inside the tenant user model, we can just extend this model over here and create a new model entirely. Now that is going to do it for our system design that covers the high level and the low level system design. So we have covered the system design, that is the episode 1 of the application. In the next one, we're going to be covering everything from models, that is going to be the authentication models. We're going to cover authentication. We're also going to cover the loan models such as the loan application, loan repayment, and then in our third episode we are going to be covering the React front end. So that is going to do it for this episode of our multi-tenant SaaS with the Django tenants and React. If you have any questions, please make sure to put them in the comments. And as always, if you found value in this content, please make sure to give the video a like, subscribe to the channel if you haven't, and also share it with other like-minded developers or person who might find it important. So that is it for today, and see you in the next episode.